Thanks everyone for joining. This is a talk on Traveler's 360-degree health assessment of microservices on the Pivotal platform. My name is Nehal Gandhi. I'm a lead architect at Travelers. I've been with the Travelers for 10 years. And joining me for this talk is Rohit.
Yeah, my name is Rohit Kelapure. I work for Pivotal for the past 5 years. My day job involves helping customers migrate applications to Pivotal Cloud Foundry. And recently, microservices seems to be the applications of de jure. So most of my time is spent either breaking monoliths down or taking existing microservices to Pivotal Cloud Foundry.
So today's agenda is I will cover just a little bit about Travelers, what they do, and also the journey of Travelers with Pivotal. And I will cover the why we did the 360-degree assessment of microservices and platform health. What was the reason which prompted us? Also, we will go in detail of how we did the assessment of dimensions, and I will present the application health check of one of our application, and we will share the best practices so that you can also do health assessment of your microservices on Pivotal platform. A little bit about Travelers. Travelers is the largest underwriter of commercial property and workers' comp insurance in the United States. Top 3 writer of personal insurance through independent agent in the United States, including number 1 in homeowners. And financially, total assets of approximately 105 billion, shareholder equity of approximately 23 billion, and total revenue of 30 billion. And we are more than 30,000 employees, and we are represented in every US states, Canada, the Republic of Ireland, United States, and the Lloyds, United Kingdom and the Lloyds. The history of a Pivotal journey. We have been the first customer to adopt the Pivotal platform. We started with the Pivotal back in May 2015, and since then we have set up a non-production and production environment in September of 2015. And our first production application on Pivotal platform was in September 2015. So we were early adopters of Pivotal platform, and we have been using Pivotal platform since then. We have seen the consistent growth of application deployment on Pivotal platform, and we have 13 major upgrade of platform with a 0 downtime of application. So we are very happy with the Pivotal platform, which provides additional capabilities for us to run our application in a distributed fashion. What prompted us to do the 360-degree health assessment of our application platform? So one of our application called Model as a Service, which is MaaS, which is a key microservice that allows our business to do the predictive analysis on a quoting service. It runs the machine learning algorithm in the real time and provides a business insight on a transaction. So do we take the risk or not take the risk based on the quoting service that coming in? And it was having issues while in production. It was having issues of having high number of threads spawning up. It was increasing in the response time. We saw high CPU utilization, and we were not able to pinpoint what was the issue while in production. And we never experienced that particular case scenario in the lower region or in our performance environment. So we were wondering, is this application or there is some differences between the production environment and the lower region that's causing this issue. And since we have working with Pivotal with high open ticket, and we provide all the information, and Pivotal support were not able to pinpoint what was the issue that causing our application to behave this way. And we also have a circuit breaker open, and which allow circuit breaker trips because of the latency on our response time, and cause business a significant amount of loss due to the risk acceptance of the risk on transactions. So we engaged Pivotal and wanted to do 360-degree health assessment of our application and platform to identify the issue lies within the application or in the platform. And we laid out the key objectives for our assessment. One is the architecture assessment. We want to make sure that the application we have deployed is mature enough for a Pivotal platform. And since we have been using the Pivotal platform since 2015, so we are in the next level of maturity on the deploying distributed application. And our application architecture roadmaps are aligning And also, since business was suffering from this issue, they were losing confidence in our application platform, and we wanted to regain that confidence by doing the assessment. It was a 2 weeks engagement with a Pivotal, and we have a Pivotal consultant come on Traveler's side, and we work with the Pivotal consultant. And approach we took is to understand the current state, define the objectives and key outcome of this assessment, perform architecture retrospective, and assess the microservice design. So the design for this application is the right microservice approach and Pivotal platform alignment. Identify risk and mitigation strategy. Review the source code, since it may be caused by the application that cause a high number of CPUs utilization or number of thread spawning. Assess the architecture health and align engineering metrics with SLO, and review the path to production. So this was the approach we took while within the 2 weeks during this engagement. And Rohit is going to go in detail on the approach.
All right. So basically, when your application has issues, when I say application, I mean whatever the system you have. It could be one service, it could be a monolith, it could be multiple services, right? So at a high level, what we see from experience is that the issues break down along 3 vectors. One, it's a people problem, right? The development team is not talking to the operations team. The developers themselves are fighting amongst one another. There are too many architects on the team. There are too many team leaders on the team. There's just too many meetings and decisioning and not enough action. So there is a people dysfunction aspect. And as a result of people dysfunction, the tools and the processes also change, and that could lead to systemic problems with your application. So don't underestimate the people aspect, and the people aspect can repeatedly cause these problems. The other 2 things are the obvious ones, which is there's an issue with the application itself. It was not architected correctly. You optimized early. Maybe you picked the wrong paradigm. You should have used synchronous instead of asynchronous, whatever, right? So there are issues with the application architecture and implementation that could be a cause of your root cause of your issues. And the third aspect is the platform itself. Like, do you have an understanding of how the platform, the Pivotal platform, is laid out? Is Cloud Foundry configured in the correct fashion? Is your application dying because it doesn't have enough memory? Is it because the Pivotal platform has been installed on disks that are not high capacity, and that your applications are dying due to disk failures, right? The platform itself, if it is not set up in a reference architecture, it could cause issues for the applications. You need to understand that. So these are the 3 vectors along which we see issues around applications. So next is, how do you dive deeper into an health assessment? Just like how when you go to a doctor, he checks a lot of things, right? He runs a complete blood work of your body to look at your cholesterol, to look at your statins, to look at the various mix of various entities in your blood. That's a similar way in which you run a health check. Now, these are the 10 things that we found are critical in a health check. Now, you will ask me, whoa, this is a big list. I can't run all of this. Now, this is where the skill part comes in. As an expert, as a tech lead, as an architect, you need to hone in on 2 or 3 of these, form a hypothesis, and run with it to see if your hypothesis is correct. I will briefly cover all of these in a very fast fashion. One is monitoring and metric, obvious, right? But even though this is obvious, customers get it wrong all the time. Make sure that you have a visibility into your application. So many times I have been brought into an incident and there are no legitimate logs or metrics. So always have your logs and your metrics and your end-to-end traces handy, right? This is the basics. If you have logs and metrics and traces, you can debug any problem, right? So monitoring. Second is failure mode analysis. When shit does go wrong, and it will, guaranteed, make sure you do an analysis of why the problem occurred and break it down along the 5 whys. We have an approach of how to do this. It's called fishbone analysis. I will explain how this is done. Third is technical debt. Okay, every time you take a pass on some feature and you say, okay, we'll do it in the next iteration, you're accumulating technical debt. Sometimes it just balloons too much and it blows up, right? So understand where you have gathered the technical debt. You may have to pay it down. Some of the technical debt concepts align with the SRE practices as well, right? So I'll explain how technical debt aligns with SRE practices. The third one is emergency response. problems do occur, it's important for, especially for a production application, that you understand the series of steps that you take to remediate it once the problem hits. I was in a production incident on Friday, right? And it was handled in a way that was, let me just put it in simple terms, not very good. What happened is, first a particular developer started addressing the problem, then 3 other developers joined him, and the 4th guy joined him. All of them were doing different things. Then the manager started hovering around them. This is not the right way to do incident management. You need to have one person to take point, who circulates the information out. Read the chapters on incident management from the Google SRE book, that they serve as a good template. Performance optimization. Performance optimization is very tricky, right? Why is the application starting slowly? Over here, a lot of the architects and developers have theories as to why this application behaves slowly. And when we do an health assessment as a third party, I come in, I objectively assess all the theories, but they are all just theories. You have to run the numbers to kind of eliminate each theory one by one. Performance optimization is rife with people thinking they know the problem, they know the solution, right? But it is important to measure. Without measuring and running your hypothesis and seeing the results, you are not really doing performance optimization. If you don't do that, you're just doing raw conjecture. Change management. Change management is important. Once your app hits production, which it will, change management, understanding the impact of a change and rolling it back becomes critical. Oftentimes, I have seen customers use, you can use like dark mode to release your application and send some traffic to it, see its performance, and then turn it on live. For risk averse, if you're risk averse, I think that's a good strategy, where you release a subset of traffic to the application that's in dark mode, validate that it is processing all the things that it is doing correctly, and then turn on the full traffic. Architecture, I'm not going to go deep into it, we'll cover more of it later, but 2 things to check in architecture. If you have a microservices based architecture, do you have too many microservices, right? Like, have you gone completely crazy? Like, what is the right level of granularity of your microservice? Like, when you change microservice 1, do you have to change 5 other microservices with you? There are 6 reasons why something should be a microservice, and we run an exercise where we evaluate all the microservices against those 6 factors, and then we come up with recommendations on whether you need to merge your services or maybe you need to split some of them apart. Platform as a product, this is mostly on the platform side, but if you think that your platform is the issue, then there's a set of things that you need to do around platform as a product. Skipping this for now because this is primarily an application focused health check. Balanced team, it's important to not just have developers, but also performance guys, true DevOps, right? Usually, if you build it and you own it, you understand this very well, that you need support from the infrastructure team, you need support from the platform team. In some cases, you may be that person. And so your team needs to be balanced. It needs to have not only developers, but also people who test, people who release the code. You should have the ability to roll stuff back. And the last is process and path to production. This is important to focus on, because what happens is, this is primarily around CI pipelines. Your CI pipelines have to be optimized so that your code changes get automatically released and tested across all the environments, and you have a proper appropriate flow for releasing it to production. I have seen a lot of dysfunction around path to production, where the process amount of approvals that it takes to hit production is too high, or the right level of testing is not being done at every stage. So these are like 10 things, right? You need to see, as an architect and a team lead, decide what are the things that you want to focus on, and then dive deep. The next part of this presentation kind of gives you a clue as to what dimension, there are 10 dimensions to attack and assess your application on. Okay, so these are the 10 things. What are the concrete things that you will do in a health check, right? I will not do all of them, but let's take a case in point. If you have a big application, right, a monolithic application that was running on Java 8, for instance, and you migrated to Java 11, suddenly your default garbage collection algorithm has switched now to the generational garbage collector. Your application may start dying due to out of memory. So then at that point, you have to indulge in JVM garbage collection tuning. You need to start collecting the garbage collection logs to see the health of your application. So there is a lot of things that you can do. This is more of a reference, but it ranges from monitoring, making sure your application is visible in the APM. It ranges failure mode analysis, Kiosk testing. You have, if this is an NFL game, this is a collection of defensive and offensive plays, right? Or if it's a football game, these are all the things like combinations that you will run. There are also equivalent things that you look at on the platform perspective. Does it have disaster recovery? Do we have the right capacity in the platform? What is the schedule for updating and putting patches on the platform? And there is a set of activities that is kind of common across both a platform health check and an application health check, right? So the things that are common are a balanced team. Are the teams healthy, right? Do we have the right set of service level objectives both on the platform side and on the application side? The creation and the definition of metrics is really common. The metrics may be different, but the SLIs and SLOs are to be defined on both sides. Incident management is common across platform and application. You may have an incident, the application teams need to understand how to react to it, and the platform teams need to react to it. And the reason why I have two circles here is that in Pivotal itself, we have two practices. One around application health check and application SRE practices, and a second around platform health check and platform SRE practices. So the gist of this slide is these SRE practices apply not just to platform but to apps as well. Okay, so what are the typical outcomes of a health check? How do you know if you have done a health check correctly or not? These are some of the things that should come out of it. Too many things on this slide here, so I'm going to hit the high points. One is you need to have an understanding of how messed up or how good your architecture is, right? You need to do an architecture alignment exercise. You need to figure out, do you have the right engineering metrics? Do you have the right set of objectives and key results for your platform? So the items on the left are strategic, the items on the right are tactical. On the tactical side, right, the outcome of a health check is, okay, this application is performing poorly. It has a bunch of dependencies that are bloated. We have done a bunch of performance testing on it. We have identified this root cause. We have fixed the problem, put it in production, and we can validate that the application is performing correctly. So you go through this entire exercise of defining the objective and key results, doing an assessment of the architecture, then putting in and fixing the problem, and then doing load testing at the other side. These are some of the outcomes of a health check. Towards the end, you see Kiosk testing and SRE practices. Those are important practices to kind of institute in your application group, so that when you put new changes in, you understand whether the application will sustain the amount of load that it has to sustain. And the SRE practices help keep this application alive in production. So a couple of activities here. So what you see in this picture is called a process of discovery and framing. You see the goals on the right. The first thing that we do in an assessment is we define the goals. Now one of the goals that you will see is the November incident post-mortem, right, which is the goal number 1. The second goal that you will see is number 2, which is determine root cause of the performance drift. So you identify you go through an ideation exercise. You create your goals, right? Prioritize all your goals, 1, 2, 3, 4, 5, 6. And on the pink stickies, you put down all the activities. The activities on the pink sticky align with the activities in the application circle over here. Okay, that makes sense? So that is how you create a concrete plan of a health check. Then you also discuss the risks for execution of this health check. Have we like availability of the performance environment? Right? This is a common problem. Performance environment either doesn't exist, or you are sharing it with 50 other teams, which is useless, right? So this is how a health check starts, through a discovery and framing exercise, a creation of objectives and key results, and a mapping of activities to those objectives and key results. Fishbone diagram. Now, one of the core goals of this exercise, if you saw this, was the November incident. This is where we do what is known as a fishbone failure mode analysis. So the problem occurred, there was an increase in CPU. Why did it occur? Let's pick up one of the things that happened, which is the CPU of the 0th instance never went down. So one of the instances became hot. Why did it become hot? Why did it become hot? So we need to look at, okay, what is the threading library? Is there any session stickiness in that? So for each symptom that you saw during the incident, make that as one of the arrows of the bones of the fish, and then peel back and hypothesize why this could have occurred. That's how you do failure mode analysis. And then in order to confirm those hypotheses, you create a set of actions that you see in the pink stickies below. One of the actions, I don't think you can read it, is review Dynatrace performance profiling data to understand the high CPU. So if you suffered a performance outage or an incident with your application, this is the analysis that you need to do to get to root cause. Okay, so we did this for MAS, right? And what did it reveal, right? So Neil is going to go through all these points. Well, not all the points, but maybe a couple of the highlighted ones.
Rest of time, I'm just going to hit a few points. One is a failure mode analysis. That was very important for us because we saw the issue in production and we wanted to understand what happened in production that caused our failure. And what we found is that the application was using a fork join pool and it was using a default values. It caused unmanaged threads to spawn up in production. It never recovered from the spawning of the threads. So it was an unmanaged thread that caused the issue of high CPU utilization, and also caused auto scaling to kick in. And at one point there were like 17 instances of the same application run because of high CPU, and never recover from the unmanaged threads. So what the recommendation was to use, instead of using a default fork join, use a managed thread, try to come up with the values that is applicable to your instances, and you scale out instead of scale up. So you manage, and when the heavy load comes up, you scale out, and then more instances will run and handle your load. That was one of the recommendation. And another one was the technical depth and code analysis. What we found is that our application was, the size of our application was very big, and this is because we were using a shared service library, and in shared service library we had many dependencies listed out in pom.xml, and which increased the size of the application which was using the shared service library. So at one point the size of our application was 250 megabyte, and as you know, as the size of your application increases, it takes longer time to start up in a pivotal platform. And this causes our auto scaling also. So if you have auto scaling, if your application doesn't come up in 60 seconds, it will start to create auto scaling and create new instances, and it still wait for another 60 seconds. So that was one of the issue we found. And what we did is that the recommendation was to remove the shared service library, break apart shared service library, and include only dependencies which we needed for that particular application, which reduced the size of the application, and we saw our application startup time reduced to 30 seconds. And another one I want to touch is architecture. So the reason for we had that the bloated library, because we were using the same source code to run in a cloud and also run on Hadoop platform, because it's a modeling predictive modeling analysis. So you can run in Hadoop to run your historical dark mode analysis. So we thought, okay, let's share the code. Why we rewrite the code? We can deploy the same application in cloud and also say deploy the application in Hadoop, and which cause our application to bring in the 5 application server. So with Hadoop and Spark, it has a 5 application server defined, and even the application is not using in cloud those application server. It's loaded up with application because of the part of the dependencies. So one of the recommendations, remove the Hadoop dependencies from the POM and create another module which can run on Hadoop instead of in cloud. And also we have a service to service communication, and instead of service to service, the recommendation was to use a DNS, which is a Go router DNS, so to speed up the communication between the services. And I think that's Rohit is going to do the best practice on how to do the health check assessment. Oh, achievements. So achievements, within 2 weeks we did achievements of, we did a 10 comprehensive dimension on our application. We enabled the local profiling using the Visual VM and JMeter, so that we can understand the startup time, CPU, and latency of our application before deploying it to the cloud. We resolve the performance mystery by managing our thread and using the garbage collector. And we were able to do the performance by creating isolation environment. So before this issue, we were sharing our environment for performance. So everybody is doing the performance in the same environment, not just Mars, but all other applications within Travelers. So what we ask our platform team to do is create a separate environment called isolated environment, where we can run the performance and we get a consistent result every time instead of sharing the environment and doesn't know who is causing the issue in performance. And I think that should cover, and then you can go to the practice that thing.
Okay, I think we have what,
10
5 minutes?
Yeah.
5 minutes?
That's
okay, awesome. This is even better. Okay, so who knows all the 4 golden signals of monitoring, right? Latency, traffic, saturation, and errors, right? What is your error rate, right? What is the number of HTTP requests that you are getting? In terms of latency, you always want to look at percentiles. What is my 95th percentile for the service? What is my 99th percentile response time for the service? The reason you want to look at percentiles is that in a microservices system, your microservices will get chained across one another. If you have 10 microservices talking to one another, chances are that probably one of them is hitting its 95th or 99th percentile in terms of response times. So remember, percentiles, not averages. Measure these 4 things for every microservice. I think Netflix guys added one more called capacity, not 100% sure, but at least start with measuring all 4 for all your services. Release viability, okay. This is kind of like the advanced level of metrics. So I'm gonna skip this and take you to this picture, which I like. So over on the left is the diagram which I call the 3 pillars of observability, right? You need to have tracing, end-to-end tracing across your microservices. Use Zipkin, use open sensors, open tracing, whatever. Second is logging. Log all your things. It needs to go to Elk or Splunk or some long-term log aggregator. And the third thing is metrics. Key metrics in terms of, okay, if there is a business level metric, you are processing insurance policies or external claims, some business level metric that can help you understand the state of your application. These 3 things together will help you. There are things that try across these things. For instance, the name of the RPC is common across your tracing request and your metric. And then the trace ID is common across your distributed trace and logging. You need to be able to correlate in this triangle, in this circle, go from one to the other, right? So this is why it's like the holy trinity of observability, which is tracing, logging, and metrics all correlated with one another. When it comes to metrics, you should probably also create dashboards, which you already probably have. You have an APM. But what do you observe in the dashboards? So you need to create a dashboard for your microservices health. If you see one on the left, this is a dashboard that I stole from somewhere. I don't remember where. But they have like 50 microservices, of which one is red. So there's the microservices health dashboard. Then there's feature success, which is, okay, I release this feature. Is this feature working, right? So there is a feature success dashboard. Then at a higher level, you can have organizational OKRs getting tracked based on the features. And then the platform itself defines its dashboard for health and for SLIs and SLOs. You need a single pane of glass where you can understand the health of the platform, the health of all the applications, and if in your case individual features are important, then the health of your individual features. These are the dashboards that you need to create and be confident that your application can live in production. And if there are issues, you can go from you can take a trace ID from log, look it up in the distributed trace Zipkin, identify the span, and then take a look at the metric that is being affected. So these 2 tie in together. In terms of features, now I'm going into the SRE for apps. Remember that you should release new features only if your service level indicators, your key metrics are adhering to your service level objectives, right? You don't want to release new features if you're already in a red state, right? Like if in video game analogy, like you don't launch an attack if you're in red health, right? So basically this is in a very sophisticated fashion, this is all the SRE advice boiled down to one slide. Is only if your key service level indicators are below your service level objectives should you release software. This is a more mathematical picture. But the one thing I want you guys to take away is see this cost of keeping the platform, like the cost and effort of keeping a platform or providing a 99.999 level of availability goes very high as your as the downtime requirements become lesser and lesser. Put it in another way, if some business user comes and says, hey, I want 99.999% availability, then you ask them, what does that mean? That means that you're only giving us 24 seconds of downtime in a whole year. What if you, that's what they're really asking, that the downtime is going to be like 30 seconds. And in order for you to do that, you need to have automated rollback, automated failover, like you need to have all those practices to go along with it. So keep this chart handy. If someone asks you, I want 99.99%, you show them this is what it means from an effort perspective, right? So economics of reliability is awesome for engineers to talk to managers when they start talking BS and keep asking you more nines of availability. Last thing is kiosk testing. Kiosk testing or load testing, remember, it's just like normal testing. First, before you launch into kiosk testing, create a hypothesis, understand the steady state behavior. If I inject this change, this is what I expect to happen, then measure that change. Kiosk testing is just like normal testing. Remember, it's all about formulating the hypothesis, calling it, and then measuring it. Lastly, it doesn't have to be very complex. Like there are a couple of links here, but the load testing can be done with very simple tools. You don't need like expensive load, just like the Apache Workbench or like JMeter, or like there are, like click on that blog post. You will see all these tools that developers can run without any kind of expensive licenses, and like how can you use to create tools to create kiosks. Generally, it's a bad idea to bring down your entire app in production. So I advise don't do that. But if you want to play around and create kiosks in your dev and test environments, you should absolutely do that. That's it. That's all I had. Hopefully, take this back, incorporate some of this into your app, microservices, and keep them healthy for a longer time. Thank you.